We want to improve our quality of life, but we need to decouple that from our use of resources. And therefore, autonomous vehicles are really an option to make people share vehicles and use our resources more efficiently. Instead of selling a product, the vehicle, we develop a mobility service that is based on fully autonomous vehicles. People like the comfort, the flexibility and the privacy of their own car. And in order to replace the privately owned car with a mobility service, we need to address those needs. We are aiming for using a custom-built AD vehicle that is really designed for this new business case of sharing rides with strangers. Our simulations say that one Sango vehicle can replace 5 to 10 privately owned cars. The more problems a city has with congestion and parking, the better for our solution. Our intention is that this will become a reality in 2024. And it will cost less than half of what it costs to own a car. The business model and how we operate the service needs to be coupled to the technical development. Whenever we find out that something is difficult technically, we need to take that in account in our business case. And for us, the simulation environment is just a perfect way of doing that.
We really need to keep track on the digital twin. So for every vehicle out there, we need to have the data in our systems. We need to know exactly what's in each vehicle. So even from the concept phase, where we put the requirements on our product, to the end phase when it's leaving the production line and going out to the customers, and even when the customers are using it, we need to keep track of the digital twin. Our vision was to move the CAE world closer to the CAD world, closer to Team Center in this case. That's why we stepped into the Sim Center world when it comes to CAE, and we approached Siemens, and they were up for the partnership. And together we have developed it. So in some areas, Siemens have pushed us to improve and step into the new era of simulation. And in some cases, we have actually been the one pushing Siemens, taking even further steps towards the digital thread and traceability.
We've been working very intensively with Siemens team, and we try to develop a process with traceability. From the CAD model, we take that from Team Center, and then we do meshing, and then we do the connection, and then we do the analysis, and then we do the post-processing, and we do the reporting. And we want to develop a process with digital thread, so we can know at a certain point the model is related to the CAD design and so on and so forth. We always do a lot of iterations from day one to you can actually see the vehicle on the road. So every iteration, we probably would run a simulation now. And those type of traceability from the design to the simulation for each iteration is vital actually. We need to make that traceability so we know the actually simulation results is reflecting the current design. Otherwise, we're not doing the right stuff.
The CAE engineers are working in the Team Center environment. So one very much a big advantage is time saving and quality assurance. Before we had a lot of manual repetitive work, and that has been changed. The meshing and the connections and etc. are automated now. Totally different speed in responding with CAE results back to the engineers developing the vehicle. It's crucial to get the products out on the market quite fast, and then it requires that we have fast tools when developing the vehicle. When you need to do a new assessment, you can actually reuse quite a lot. It's already existing in the database, and you can feel confident that you're using the correct data. Everything is very transparent and open for the rest of the organization.
The simulation environment is really the magic key to unlock many of those problems. It's not that you just magically have the solution, but it's at least a tool how you can iterate towards a better and better solution.